In this video, we are going to talk about how to add, subtract, multiply, and divide complex numbers. In the 1500s, a certain mathematician attempted to solve a question. And then the question was, find two numbers whose sum is 10 and whose product is 40. So let's try solving the question. We want two numbers whose sum is 10 and then whose product is 40. So let's write equations. Let's assume the numbers are A and B. So the sum of the two numbers, A plus B, is equal to 10. And then the product of the two numbers, AB, is equal to 40. So this is equation 1 and this is equation 2. So let's make A the subject in equation 1. So from equation 1, A is equal to 10 minus B. This is equation 3. So let's put equation 3 in equation 2. So 10 minus B times B is equal to 40. And so let's multiply through by B. 10B minus B squared is equal to 40. And then let's take everything to the right hand side. So B squared minus 10B is equal to plus 40 is equal to 0. So let's solve for the values of B. You can see that this equation is of the form ax squared plus bx plus c equals 0. So we need to use the quadratic formula. And the quadratic formula, it says that x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. And in this case, x is b, so b, capital B, is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So what is b? B in this case is minus 10. So minus 10 plus or minus square root of minus 10 squared minus 10 squared minus 4 times a. A is the coefficient of b, and that is 1. A is the coefficient of b squared, that is 1. Then c is 40 divided by 2a, that is 2 times 1. So b is equal to, here is minus 10, so minus 10. So it becomes 10 plus or minus square root of 100 minus 4 times 40 is 160 divided by 2. So b is equal to 10 plus or minus 100 minus 160 is minus 60 divided by 2. So if we divide 10 by 2, it's equal to 5. So b is equal to 5 plus or minus. Then we need to find square root of minus 60 divided by 2. This is where the problem of complex numbers come in. How can we find two numbers such that when we multiply those two numbers, we are going to get minus 60? You see that this is mathematically not possible. Mathematicians refer this to as imaginary numbers. So we need to imagine some numbers that when we multiply, we will get this square root of minus 60. So in that instance, what we can do is that we can factorize the square root of minus 1 out. So So this can also be written as b is equal to 5 plus or minus square root of 60 times square root of minus 1 divided by 2. So b is equal to 5 plus or minus square root of 60 is the same as 2 root 15 divided by 2 times square root of minus 1. So this 2 and this 2 can cancel, and b is equal to 5 plus or minus square root of 15 times square root of minus 1. So you can see that at the end of the day, we've gotten answers that are not real. These are not real numbers. So mathematicians have then referred to this square root of minus 1 as I. So therefore, b is equal to 5 plus or minus square root of 15i. And let's solve this other question. Solve x squared plus 9 equals 0. So x squared is equal to minus 9. So we take square root of both sides. So x is equal to plus or minus square root of minus 9. You can see that we can't find two numbers that when you multiply, you will get minus 9. And therefore, what we do is that we say x is equal to plus or minus square root of 9. We are factorizing square root of minus 1 out times square root of minus 1. And we've said that square root of minus 1 is equal to I. Or in other words, I is equal to square root of minus 1. So x is equal to plus or minus square root of 9 is 3. Then square root of minus 1 is I. So plus or minus 3i. So x is equal to 3i or minus 3i. These are the solutions to this equation. Now, your turn. Solve x plus 36 is equal to 0. So in this case, you see that x squared is equal to minus 36. So we take square root of both sides. So this and this will cancel. So x is equal to plus or minus square root of minus 36. Since we can't find two equal numbers that when you multiply, you will get a negative number, then x is equal to square root of 36 times square root of minus 1. So x is equal to plus or minus square root of 36 is the same as 6. And square root of minus 1 is I. So plus or minus 6i. Now let's solve this one too, which is 2x minus 7 is equal to 4x squared. So let's bring all of this to the right hand side. We are left with 4x squared minus 2x plus 7 is equal to 0. So we need to use the quadratic formula because you can see that this equation is of the form ax squared plus bx plus c is equal to 0. So x is equal to x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. So x is equal to minus b is b is minus 2, so minus 2 plus or minus square root of b squared, which is minus 2 squared, minus 4 times a. In this case, a is 4. Then times c is 7. So this is equal to 2 plus or minus square root of minus 2 squared is 4, minus 4 times 4 is 16 times 7 is equal to 112. All divided by, I left something out here. Here was divided by 2 times 4 So here will be divided by 8. So x is equal to 2 divided by 8 is 1 over 4, plus or minus square root of 4 minus 112 is minus 108 divided by 8. So x is equal to 1 over 4 plus or minus. So we can factorize minus 1 out of this. So we left with square root of 108 divided by 8 times square root of minus 1. And then we've established that I is equal to square root of minus 1. And therefore, x is equal to 1 over 4 plus or minus square root of 108 can be written as square root of 27 times square root of 4 and times square root of minus 1 divided by 8. So square root of 4 is 2. 2 divided by 8 is 1 over 4. So x is equal to 1 over 4 plus or minus square root of 27. So 1 over 4 times square root of 27. Then square root of minus 1 is I. So finally, x is equal to 1 over 4 plus or minus I square root of 27 divided by 4. You can see that in all the examples that we have done, all the numbers that we got, the complex number z is in the form of a real number. Like in this case, this is 1 over 4 is a real number, then plus the complex part of the number, which is ib. Anytime you see a number of this form, then you are talking about a complex number. Any complex number has a real part and then an imaginary part. So the real part is denoted as real part of z. So in this case, real part of z is equal to a. And then the imaginary part is represented as imz. And in this case, it is equal to b. So the part with the I attached to it is the imaginary part, and the part with no I attached to it is the real part. So in this case, for example, this complex number, the real part is 1 over 4, and then the imaginary part is root 27 over 4. Let's talk about addition and subtraction of complex numbers. Let's assume that we have z, which is equal to 3 plus 5i, and we have w, which is also equal to 2 plus 3i. What is z plus w? It's equal to, so what you do is that you add the real part and then you add the imaginary part. So z plus w is equal to, the real part of z is 3 and the real part of w is 2, and plus the imaginary part of z is 5. Then the imaginary part of w is 3i. So this is equal to 3 plus 2 is 5. Then plus 5 plus 3 is 8i. So it becomes 5 plus 8i. What about z equals 7 plus 2i? And then w equals 6. What is z plus w? It's equal to, so you add the real part, which is 7 plus 6, and then plus the imaginary part is 2 plus. Now this w can be written as w equals 6 plus 0i. So 2 plus 0i, and this is equal to 7 plus 6 is 13, and then 2 plus 0 is 2, so it becomes 2i, and therefore the z plus w is 13 plus 2i. Now let's talk about subtraction of complex numbers. Let's assume we have z equal to minus 6 plus 9i. And we have w equal to 2 minus 3i. What is z minus w? It's equal to, at one side, so minus 6 is the real part of z and 2 is the real part of w. So you subtract the real part. You can minus 6 minus 2, then plus. Then you subtract the imaginary part, which is 9 minus 3i. So this is equal to minus 6 minus 2 is minus 8. And then plus 9 minus 3 is 11. So this is 11i. So z minus w is minus 8 plus 11i. Let's talk about conjugate of a complex number. Z is equal to a plus ib. So the conjugate of z, which is denoted as z with this little line on top of it, is equal to a. Then you change the sign of the imaginary part, minus ib. So that is the conjugate of z. So let's assume we have w equals minus 3 minus 4i. What is the conjugate of w? It's equal to minus 3 plus 4i. And let's assume we have z equals 6. What is z? The conjugate of z. Now z plus 6 can also be written as z equals 6 plus 0i. So the conjugate of z is equal to 6 minus 0i. And 6 minus 0i is the same as 6. So this means that anytime you find the conjugate of a real number, it is the same number, unless the number has a complex portion. Unless the number has an imaginary part before you can do any changes to that number. Let's talk about multiplication of complex numbers. Let's assume that we have z equals a plus ib, and we have w equals c plus id. Then what is zw? The multiplication of z and w. What you do is that you will multiply a and c, and then you subtract it from b and d, the multiplication of b and d. Then you add it to a, d. In other words, you cross multiply, then plus b, c, i. So this is how to multiply complex numbers. So for example, let's assume we have this complex. Let's multiply this complex number. 2 minus 7i, then times 3 plus 4i. So let's multiply these two complex numbers. So what we said is that multiply 2 and 3. So it's equal to, so this is equal to 2 times 3. Then you subtract it from, you multiply 7 and 4. In this case, it's minus 7 times 4. Then plus, you multiply 2 and 4. Then multiply 7 and 3 and add. So in this case, it is 2 times 4. Then plus minus 7 times 3. I. So this is equal to 2 times 3 is 6. Then plus minus minus is plus. So 7 times 4 is 28. Then plus 2 times 4 is 8. Then minus 7 times 3 is 21. I. And this is equal to 6 plus 28 is 34. Then 8 minus 21 is 13. So 34 minus 13i. What if we were given 5 plus 12i and to multiply with 6 plus 7i? So this is equal to multiply 5 and 6, so 5 times 6, and multiply 12 and 7 minus 12 times 7, then plus, you cross multiply. In this case it will be 5 times 7 and plus 12 times 6 I. So 5 times 6 is 30 minus 12 times 7 is 84, and plus 5 times 7 is 35, plus 12 times 6 is 72 I. 30 minus 84 is minus 54, and then plus 35 plus 72 is 107, so 107 I. This can be written as equal to 2 plus I times 2 plus I. And so let's go ahead and multiply. This is equal to, you multiply the correspondent, which is 2 times 2, then minus this I has a coefficient of 1, times this I also has a coefficient of 1, then plus, you cross multiply, so 2 times 1 plus 1 times 2. And this is equal I. There's an I here. This is equal to 2 times 2 is 4, minus 1 times 1 is 1, plus 2 times 1 is 2, and plus 1 times 2 is 2 I. 4 minus 1 is 3, plus 2 times 2 is 4 I. Sorry, 2 plus 2 is 4 I. So the answer is 3 plus 4 I. Now let's look at an alternative. What you could do is to use the traditional way of multiplying numbers. So 2 plus I times 2 plus I is equal to, or this is equal to 2 times 2 plus I, then plus this I times 2 plus I, and this is equal to 2 times 2 is 4, then 2 times I is plus 2I, then plus I times 2 is 2I, then plus I times I is I squared. So this is equal to 4 plus 2I plus 2I is 4I, then plus I squared is minus 1, so here become minus 1. 4 minus 1 is 3, so 3 plus 4I. And it is the same as the answer we got. Any of the methods you use, you should get the same answer. So you can pause the video and try this example, which is expand 3 minus 3I exponent 3. So what we can do is we can write this as, we can factorize 3 out of the question. So if you factorize 3, it will be 3 exponent 3 times, here we'll be left with 1 minus I cubed. 3 exponent 3 is 27, so this is equal to 27, and then times 1 minus I squared times 1 minus I, because we said this is 1 minus I cubed, so we can factorize 1 minus I out, and we'll be left 1 minus I squared times 1 minus I. So this is equal to 27, then times, let me bring 1 minus I first, 1 minus I first. And then 1 minus I squared is equal to 1 squared, then minus 2 times I, minus 2 times 1 times I, then plus minus I squared. So this is equal to 27 times 1 minus I. 1 squared is 1. Then minus 2 times 1 is 2 times I. That becomes minus 2I. Then here is minus I squared. So in other words, let's solve it. Let me do it down here. Minus I squared is the same as, you can factorize minus 1 out. Minus 1 squared, then I squared. So this is equal to minus 1 squared is 1 times I squared is minus 1. And 1 times minus 1 is minus 1. Therefore, minus I squared is minus 1. So this is equal to 27 times 1 minus I, and times 1 minus 1 is 0. So minus, we'll be left with minus 2I. And this is equal to 27 times minus 2I is minus 54I times 1 minus I. And this is equal to minus 54. I times 1 is I. Then I times minus I is minus I squared. Now, what is minus I squared? It is equal to minus 1 times I squared. And we said I squared is minus 1. So this is minus 1 times minus 1, which is equal to 1. So notice the difference. Minus 1 minus I all squared is equal to minus 1. But minus I squared is equal to 1. And therefore, this is equal to minus 54 times I minus plus 1. Now let's talk about division of complex numbers. Let's assume we have this complex number, which is 4 plus 7I divided by 2 plus 5I. How do you simplify this complex number? The way to do it is by finding the conjugate. Remember, we said that if we have a complex number z equals a plus ib, then the conjugate of z is equal to a minus ib. So we need to find the conjugate of the denominator and multiply both the numerator and the denominator by the conjugate. In this case, the conjugate is 2 minus 5i. So we multiply this by 2 minus 5i divided by 2 minus 5i. This is equal to 4 times 2 minus 5i plus 7i times 2 minus 5i divided by 2 times, you can see that this is difference of 2 squares. So this becomes 2 times 2 plus 5i times minus 5i. So this is equal to 4 times 2 is 8. Then 4 times minus 5i is minus 20i. And plus 7i times 2 is 14i. Then 7i times minus 5i is minus 35i squared. Divided by 4, 2 times 2 is 4. Then minus 5i times minus 5i is minus 25i squared. And this is equal to 8. And then minus 20i plus 14i is equal to minus 6i. Then minus 35 times I squared. Remember, we said I squared is minus 1. So it's minus minus 35. It becomes plus 35 divided by 4. Then minus 25i squared is plus 25. This is equal to 8 plus 35 is equal to 43 minus 6i divided by 4 plus 25 is 29. So simplify 4 plus 5i divided by 6 minus 5i. Pause the video and try. So this is 4 plus 5i divided by 6 minus 5i. Now the way to go about it is by multiplying the numerator and denominator by the conjugate of the denominator. So this will be times. The conjugate is 6 plus 5i divided by 6 plus 5i. And this is equal to 4 times 6 plus 5i, then plus 5i times 6 plus 5i divided by 6 times 6, then because this is difference of two squares, then minus 5i times 5i. And this is equal to 6 times 4 times 6 is 24. Then plus 4 times 5 is 20i. And plus 5i times 6 is 30i. Then plus 5i times 5i is 25i squared. Divided by 6 times 6 is 36. Then minus 5i times 5i is minus 25i squared. And this is equal to 24. Then 20i plus 30i is equal to plus 50i. Then plus 25i squared is minus 25 because I squared is minus 1. Divided by 36. Then minus 25i squared is minus 25 times minus 1, which becomes plus 25. This is equal to 24 minus 25 is minus 1 plus 50i divided by 36 plus. So we have this question here. Simplify 2i divided by 1 plus 2i into bracket 1 plus 2i all squared. So pause the video and try. So what we must do is that we need to first take the denominator and solve. So let's solve the denominator first, which is 1 plus 2i squared. This is equal to 1 plus 2i, then times 1 plus 2i. And this is equal to 1 plus 1 times 1 plus 2i, and plus 2i times 1 plus 2i. This is equal to 1 times 1 is 1, plus 1 times 2i is 2i. Then plus 2i times 1 is 2i, plus 2i times 2i is 4i squared. So this is equal to 1 plus 2i plus 2i is 4i. Then 4i squared, I squared is minus 1 times 4 becomes minus 4. So this is equal to 1 minus 4 is minus 3 plus 4i. So this is the result for the denominator. So the question then becomes 2i divided by minus 3 plus 4i. So you can do this by multiplying the numerator and the denominator by the conjugate, which is minus 3 minus 4i divided by minus 3 minus 4i. So this is equal to 2i times minus 3 minus 4i divided by minus 3 times minus 3, then minus plus 4i times minus 4i. And this is equal to 2i times minus 3 is minus 6i. Then 2i times minus 4 is minus 8i squared. Sorry, it's 2i times minus 4i. divided by minus 3 times minus 3 is 9. Then here is 4i times minus 4i is minus 16i squared. So this is equal to minus 6i, then minus 8i squared becomes plus 8 divided by 9, then minus 16i squared becomes plus 16. This is equal to 8 minus 6i divided by 9 plus 16 is 25. So the final answer becomes 8 divided by 25, then minus 6i divided by 25. To bracket 1 plus 2i all times z is equal to 2i, 2 plus 5i. Find z. So what we can do is that we can divide through by 1 plus 2i. We can divide here 2 by 1 plus 2i. And therefore z, this and this will cancel out. Is equal to 2 plus 5i divided by 1 plus 2i. So we multiply both the denominator and the numerator by the conjugate of the denominator, which is 1 minus 2i. This is equal to 2 times 1 minus 2i, then plus 5i times 1 minus 2i divided by 1 times 1, then plus 2i times minus 2i. So because this is just difference of two squares, let me rather do it 1 squared minus 2i squared. This is equal to 2 times 1 is 2, and 2 times minus 1, and minus 2 times I is 4i. Then plus 5i times 1 is plus 5i. Then 5i times minus 2 is minus 10i. Divided by 1 squared is 1, then minus 2i exponent 2 is equal to 4i squared. And this is equal to 2, then minus 4i plus 5i is plus I. Here is 10i squared. Then minus 10i squared is plus 10 divided by 1 plus 4. So this is equal to 2 plus 10 is 12 plus I divided by 5. And therefore the final answer is 12 divided by 5 plus I divided by 5. Solve the simultaneous equation for x and y. 3 plus 5i plus x minus yi equals 6 minus 2i. And 3 plus yi equals into bracket 1 minus I times into bracket 2 plus 8i. So let's start with, so let's say this is equation 1 and this is equation 2. Let's start with equation 1. Let's make x and yi the subject here. So this becomes x minus yi equals, we are taking all of this to the right hand side. It becomes 6 minus 3, then minus 2i. This 6 minus this 3, then minus this 2i minus 5i. So x minus yi is equal to 6 minus 3 is 3. Then minus 2i minus 5i is minus 7i. So this is equation 3. Sorry, I made a mistake here. This is x, this is not 3. So let's take equation 2. It becomes x plus yi equals, let's expand this. That is 1 times 2 plus 8i. Then minus I times 2 plus 8i. So x plus yi is equal to 1 times 2 is 2, and plus 1 times 8i is 8i. And minus I times 2 is minus 2i, and minus I times 8i is minus 8i squared. So x plus yi is equal to 2 Then 8 minus 2i is plus 6i. Then minus 8i squared is the same as minus 8 times minus 1, which is plus 8. So x plus yi is equal to 2 plus 8 is 10 plus 6i. So this is our equation 4. So let me write the equation 3 beneath it. We got equation 3 as x minus yi equals 3 minus 7i. So this was equation 3. We are looking for x and y. So what we need to do is, you see that here is plus and here is minus. So if we add equation 4 and equation 3, the yi will go away. So let's add equation 4 and then equation 3. We are going to get, okay, so let me continue from the top here. 4 plus 3, equation 4 plus equation 3. And this is equal to x plus x plus yi minus yi. Sorry, x plus x plus yi minus yi equals 10 plus 3 and then plus 6i, then minus 7i. So x plus x is 2x, then plus yi minus yi is 0 is equal to 10 plus 3 is 13. Then 6i minus 7i is minus i. So you can divide through by 2 and divide through by 2. This 2 and this 2 cancels out. So x is equal to 13 divided by 2 minus 1 divided by 2i. So this is the value of x. Let's look for y. Now what we can do is that we can subtract equation 3 from equation 4 so that x and x will go away. So it becomes, so let's do equation 4 minus equation 3. It becomes x minus x. So it's here, x minus x. Then plus yi, then minus yi. And when we come here, it becomes equal to 10 minus 3, then plus 6i, minus 7i, minus 7i. So this x and x will cancel, so that will be 0. Yi minus yi is 2yi equals 10 minus 3 is 7. Then 6i minus 7i is plus 13i. So let's continue. So what I want to do is, I want to rewrite this as 2i times y equals 7 plus 13i. So that you can divide through y, 2i. Divide here 2i, 2i. This 2i and 2i will cancel. So y is equal to 7 plus 13i divided by 2i. Now what we can do here, let me continue from here. Y is equal to 7 plus 13i divided by 2i. What we do here is we need to rationalize by multiplying both the numerator and denominator by I. So y is equal to 7 times I is 7i. Then 13i times I becomes 13i squared, which becomes minus 13, divided by 2i times I becomes 2i squared, which becomes divided by minus 2. So the minus can go up, and if the minus goes up, it becomes equal to 13 divided by 2, then minus 7i divided by 2. Therefore, x is equal to 13 divided by 2 minus 1 over 2i. Then y is equal to 13 divided by 2 minus 7 over 2i.